Hi and welcome to this video on the product rule. If you haven't already, please go back and watch the video on the chain rule because we will be using the chain rule when going through the examples for the product rule. So I'm going to start with a brief explanation of what the product rule is, and then we're going to launch into an example. So if we have a look here, what we've got is this function f of x, and it's equal to two functions multiplied by each other. So in this case, u of x, v of x. So how would we find the derivative of these? Well, we could go through, multiply this function by this function, expand it all out, find the derivative, and then factorize it all afterwards. It would just get messy, especially when we're talking quite large functions or if you've got big powers involved. So we've got this rule called the product rule, which will make life really simple for us. So f-x, which is our derivative, is just equal to the derivative of u of x multiplied by v of x. That's not the derivative of v of x, it's just v of x, plus u of x, just plain old u of x, multiplied by the derivative of v of x. So how is this going to look in an example? Let's have a look. So we've got a function, and I'm going to use y, is equal to the square root of x multiplied by 2x plus 1, all to the power of 3. Now, if we think about this for a moment, we've got, I want you to pause the video and try and work out where are the functions here. Think about it for a moment and see if you're right. Okay, hopefully you've had a bit of a look. So we've got one function here, which is the square root of x, another function here, which is 2x plus 1 cubed. We've really got an extra function, and that's this 2x plus 1 here as well. So you see, when we try to differentiate this part of the function, we're going to have to use our chain rule. So let's have a look at what this is going to look like. So y dash. So we take the derivative of the square root of x. So rationalize it first so that if we've got the square root of x, it's going to equal to x to the power of a half. If we take the derivative of this, we should end up with a half x to the power of minus 1 over 2. Multiply it by all of this, 2x plus 1 to the power of 3. Leave it as is. Then we're going to add the square root of x. This is it, just this part, leave it by itself. Multiplied by, and this is where things are going to get really interesting, the derivative of this function here. As I mentioned, we have to use our chain rule. So we've got, remember our chain rule is the derivative of the entire thing multiplied by the derivative of the function inside. So you should have something that's 3 multiplied by 2x plus 1 to the power of 2, remembering that that's the derivative of that section, multiplied by the derivative of the inside here, which is just 2. Let's simplify this a bit. And let's look at simplifying this section here. You can go through and simplify this section here if you want to, but you don't have to at the moment. A half x to the power of minus 1 over 2, 2x plus 1 to the power of 3, plus the square root of x. Now these two terms here, the 2 and the 3 can be multiplied together, is 6. X should be 2x. 2x plus 1 all squared. And that's just how the product rule works. Now, it is a bit messy trying to deal with bits and pieces and going along like that. So what I'm going to show you guys is a bit of a simpler way, again, like I showed you in the chain rule, using U substitution, or in this case, U and V substitution. So let's scroll down a bit. Using our same function as before, we're going to, let's write it out. Y equals the square root of x multiplied by 2x plus 1 cubed. We're going to let U equal the square root of x and V equal 2x plus 1 cubed. So that would essentially turn this function here into uv. See how now I've got u times v, except it's slightly different. Exactly the same though. So let's go through and individually work out what are the derivatives of u and v. So u dash is going to equal the derivative of this, which is just half x to the power of minus a half. Remember, rationalize it first, so x to the power of a half. Use our normal rule of differentiation. So, just to recap, if you got f of x is equal to x to the power of n, f dash x is equal to n, so we're taking n down there, out the front, to times x to the power of n minus 1. So hopefully that makes sense how I've gotten to this part. So, next bit, we've got to find out what v dash is. And again, we've got to use our chain rule here. So, our chain rule is going to state that we take the derivative of the overall function and then multiply it by the derivative of the function inside. So 3, 2x plus 1 to the power of 2 multiplied by 2. Remembering that 1 will just go to 0. Which makes v dash equal to 6, 2x plus 1 squared. Hopefully that makes a bit of sense. Now, we could, and I'll scroll down a little bit, substitute it into here for our derivative. So, our derivative of y, in this case, y dash, is going to equal u dash v plus u v dash. So, these are just our derivative parts here. So let's substitute these in and see what answer we get. So y dash is equal to a half x to the power of minus 1 on 2 multiplied by 2x plus 1 to the power of 3 plus the square root of x, because that's just what u is, multiplied by 6, 2x, let's make that a bit neater, (2x) plus 1 squared. And that is our final answer. Let's have a brief look, and we'll use substitution, at another example. So let's go. Don't know why that line's appearing there. It will disappear in a moment. Y is equal to x squared. X squared take 2x to the power of 4. So we're going to let u equal x squared and v equal x squared take 2x to the power of 4. So all we've done is gone, okay, let's break this function here up into two parts, having u and v. So what are the derivatives of these? So look at u first. So the derivative of u should be pretty simple and clear by now. It's just going to be 2x. The derivative of v, we're going to have to use our chain rule again. Can't get away from it. So 4 x squared take 2x to the power of 3. Let's make that look a bit more like a 3. Times 2x minus 2. Now we can go through and simplify it if we want to, but let's just leave it as that. So let's tidy it up a tiny bit. 4x squared minus 2x to the power of 3, 2x minus 2. And we'll leave it at that. Alright, let's have a look. Let's substitute it back into this formula here and see what we get. Y dash is equal to u dash first, which is just 2x multiplied by v, which is x squared minus 2x to the power of 4, plus x squared, which is u, multiplied by 4 x squared minus 2x all to the power of 3. Let's tidy that 2 up a bit. And it won't tidy up. That's alright, we'll leave it for the moment. 2x minus 2. And, right. Now, if you want to leave it like that, that's okay. However, we can simplify it just a little bit. And why wouldn't we want to? Let's simplify it. Y dash is equal to 2x x squared minus 2x to the power of 4 plus, let's get these terms together, 4x squared x squared minus 2x to the power of 3, 2x minus 2. And that is our answer. Now, it does seem a little bit long-winded to go from this to this, but that is our answer. If we wanted to, we could expand all of this out, going x squared minus 2x multiplied by itself, and another 3 times to make it 4 in total, and then multiply the whole thing by x squared, and work out the derivative from there, and we'd have to go through and expand all of this out to see if we get the same answer. But rules have been proven time and time again that this is what they are. Hopefully that makes sense. The next one we're going to go through is the quotient rule. Again, if you want to have a look through these examples in a bit more clearer manner, they're just in example 8 on page 40 of the textbook. Thank you for listening.